Hello, everyone. My name is Rick Sidler, and I'm the Director of Field Automation Scientists at Unchained Labs. I will be your moderator today. Thank you for joining us for Explode into AI-Driven Automation with Stuntman. Before we begin, just a quick note, we'll have a live Q&A session at the end of the presentation. To ask questions, all you have to do is click on the Q&A in the Zoom navigation bar. It'll be either at the bottom or the top of your screen, and type your question. When you submit your question, please avoid clicking the anonymous buttons so we can reach out via email if we aren't able to get to all the questions today. We'll get to as many of them as we can. And now I'm excited to introduce our presenter, Ruja Shrestha, Product Manager for the Workflows Automation at Unchained Labs. Today, Ruja will walk through why traditional lab automation struggles to scale and how Stuntman moves beyond traditional automation by embedding native AI into the experimental workflow. And now I'm going to hand it over to you, Ruja. Great to be with you again on another webinar.
Yeah, absolutely. Great to see you too again, Rick. Thank you so much for the introduction. Let me start sharing my screen. All right, hope that's coming through. All right. Again, thank you for the introduction, Rick, and thanks to everyone online for joining. I'm happy to be talking to you today about how Stuntman can help you go beyond traditional automation with native AI built into it. So let's get into it and let's get started. When we think about automation today, most platforms are incredibly capable from a mechanical standpoint. If you think about it, they can pipette, they can move plates, they can integrate devices, they can do your workflow. They can execute the scripts that are predefined, right? But what they lack fundamentally is really the directional intelligence, kind of like this compass that you see on the screen. So this compass is a beautifully engineered hardware, no doubt. But without orientation, without a needle, what use is it? It cannot really guide you on where to go next or where you are at this current time point, right? And that is where most automation platforms sit today. They can execute, they can run your experiments the way you want, but all of this comes without intelligence. And what that means is you don't know where your experiment is at a given time point and also where it is headed. And if there are any pitfalls ahead of you, and if you're going to be successful with what you're running. So the story actually changes when you bring intelligence into this loop. It is not about just running experiments anymore, but it's more about running experiments and making decisions without any friction. With built-in intelligence, you can suddenly see that there is a path forward that is clear, guided, and intentional. And instead of just wandering around and making wild guesses, you finally have momentum. And every step has a purpose, and every turn has a meaning. So this is exactly what Stuntman brings to the table for you in your lab automation workflow. Stuntman changes the game in lab automation with native AI-driven, fundamentally flexible automation. Stuntman platform is built with intelligence into the core of how it designs your experiments, runs them, as well as iterates experimental cycles. Stuntman is your actual hero in the lab that does not just run workflows for you, but also guides you with your steps and keeps your research moving the way you want, adapting to your science as your research evolves, which is more common than not that your science can kind of change from day to day based on the results that you get. As researchers, right, we always have these ideas that we want to try and test and run and make sure that we get to the final target. Once you have this idea, you need to turn it into something that a robot can actually run. And that usually means that you have to translate this idea into scripts, into execution steps, and also integrate it with your downstream analysis. Each of this handoff from design to execution to analysis really introduces some friction and causes delays because there's many handoffs. With Stuntman, there's a native built-in AI that will help you bridge this gap and also remove that friction with design, execution, and analysis. Everything happens on a single system for basically seamless handoff between different steps. So you can design experiments visually with drag and drop or programmatically in Python, like you see on the bottom left of this slide here. You can execute with a simple click or even trigger programmatically through an API or application programming interface, like you see in the middle of the slide. And then when results come back, you can review and report using a user interface or use AI to help interpret them, as you can see on the right side of the slide. And this is what that looks like in real life, interacting with Stuntman AI. So instead of starting with scripts, mapping plates, and parameters to create a step-by-step workflow manually, you basically start by just describing what you want to do in plain language. So point Stuntman AI to an example script file that it can use as a template. Tell it what your goal is. So for example, in this case, it is a chemistry example for nickel-catalyzed Buchwald-Hardwick amination reaction, and specify the format that you want to run the experiment in, for example, a 24-well plate. When you do that, what you end up with is Stuntman AI will generate an executable workflow based on what you've described. What you're seeing here is a design script with thousands of lines of code that Stuntman AI generated in just a few minutes. When you look at the code, what you'll see is that it defines the experiment, defines the plate format, the reagents, as well as reagent mappings, which wells they're mapped to, what the step-by-step workflow is. All in a format that can be executed by Stuntman and is also human readable, as you can see. So you can review the code and edit it if necessary before running it on Stuntman. Stuntman AI also responds in plain language, as you can see here. So it explains what it is doing based on the prompt you have provided. It explains what it understood from your request, right? So if it says, if it understood incorrectly, then you can make a correction to it. It also describes how it structured the experiment. What all of that means is that you don't have to read through thousands of lines of code that it generated just to understand the design it created. But if you want to, that code is still available, like you saw in the previous slide, at your disposal. You get the simplicity when you need it, like you can see on the screen, but also full transparency and control when you want it using the Python code that it generates. All of that control comes through the code as you saw in the previous slide, or through the GUI as you see in this slide here. So you can review reagents, plate layouts, libraries, as well as mappings, and the full step-by-step workflow using the GUI or graphical user interface. And then you can inspect and adjust and validate everything before execution if you need to. And you can also see that without you manually filling in details, Stuntman AI automatically groups all the chemicals correctly and pulls in properties like molecular weight and density. And if you had to do this manually, this could take you, I don't know, at least a few minutes or hours if you're generating very long experiments with many different chemicals and libraries. Once the design details are confirmed, either using the Python code or the GUI, then the execution is guided step by step, which includes loading your design, defining run options, configuring the system as well as the deck, so that you can feel confident about the experiment you're running without having to run into any errors when the experiment is being executed on the hardware. When experiments are running, you can track experimental progress in real time. And you can see exactly which wells are being processed, what step the system is on, the overall run status. All of that is visible through this user interface. You do have the visibility into the workflow as it executes, and also the ability to pause or abort if that is needed. There are also many other controls that are inherent to the GUI that will allow you to manage your chemicals, your tips, your different types of libraries you want to run, all using a single user interface. When the run is complete, all of the results become available in a structured format like you can see here. You can view data for an entire plate or just drill down into a single selected well or the wells that are of interest to you. You can see numerical data like dispenses and target versus actual values, see XY data like chromatograms and spectra. You can also view images. And everything, all of these data types can be tied back or are tied back with timestamps to the original design and run metadata. And using the field chooser on the bottom left of the screen, you can select exactly which data type you want to display and which wells you want to look at. You can focus precisely on the wells and parameters that matter for your decision for iterating over the next step or next experiment you want to run. All of that from a structured traceable data that we provide with Stuntman. So let's pause for a few seconds for a moment and think about what you have seen so far. What you have seen is the step-by-step view with AI creating a design, which you can run through GUI and visualize results through the GUI. But does it have to be this way? And the answer is no. In today's world, GUI is not the only way for you to interact with hardware. In today's world, running a single experiment is not enough. What you are really aiming towards is optimization. Optimization is what matters, and optimization requires that there is continuous iteration of experiments without any friction. And ideally, all of that iteration happens without manual handoffs, which could cause delays and which could cause your projects to be delayed in the overall scheme of things. Right? So this is exactly where Stuntman AI excels. You tell Stuntman AI what you want to do in plain language and drive your experiments from start to finish without the friction. So what it will do is generate the script that can create a design for you, run the experiment, log results into a central data file, analyze those results using either built-in or custom machine learning optimizer, and feed all of the results back into the next cycle. You can go basically from your original intent or idea to design, to execution, to results, and to analysis, and then back into the next iteration of your experiment very quickly without having to worry about translating your plain language into scripts that Stuntman can understand. So all of this, we've made it possible because Stuntman basically exposes APIs or application programming interface for complete programmatic control. You can access experiment designs directly. You can trigger and execute runs remotely using CELA communication. You can monitor status and handle errors programmatically. So without having to use the GUI, you have this flexibility as well. And then this allows you to basically extend Stuntman beyond a single experiment. It enables you to integrate Stuntman into a broader lab automation ecosystem, including orchestration, scheduling, and even running true closed-loop workflows. It allows you to scale from just a single system into a fully automated lab. And, no matter where you are on your automation journey, whether you are running a single system or orchestrating an entire lab, it always helps to have a good starting point. And usually in science, most often than not, when you have a starting point, it's usually a paper that we've read or maybe a published protocol or literature data that we want to reproduce. So instead of manually translating all of those into scripts and set up steps, what you can do is simply point Stuntman directly to the literature like you can see on the screen here. When you do that, what Stuntman will do is it will basically ingest all of that knowledge, interpret the protocol that's described in the literature, extract the key parameters that are needed, and translate all of that information into a design that can be executed on Stuntman. And what used to be manual translation from paper to script becomes something that's executable workflow in just minutes. And that basically lowers the barrier from, taking something published knowledge into something that can be executed on Stuntman. So what I have shown you so far is just one example, right? One chemistry example, one reaction, one workflow. But when you think about it, it's not limited to a specific chemistry or application. Stuntman is a single platform, one platform that covers a variety of different workflows. And it has been built to handle any kind of stunt, anything across pharma, biopharma, chemicals, agrochemicals, materials and energy, consumer products, and more. You name it. So Stuntman can be built to handle a different type of application, different types of workflows. All of this is supported with the intelligence and adaptable hardware that basically scales with your needs. So Stuntman is built to fit for purpose, and each system is configured and customized for your application and your specific lab automation needs. So looking at an example for small molecules and chemistry, even within small molecules and chemistry, every lab's needs can be different. They can look different. You might be focused on reaction screening, maybe looking at high temperature or high pressure optimization, or even some pre-formulation work or sample prep. And all of these priorities can change over time too. But Stuntman can handle them all, and you can actually end up mixing and matching different capabilities and reconfiguring the system as your science evolves without ever outgrowing the platform. So for example, if you're doing screening, you could imagine doing screening for reactions, for different catalysts, for different solvents, try and get real-time sampling as the reactions progress, and also map discrete and continuous variables. For optimization, again, real-time sampling becomes a critical parameter that you want to have available. You want to be able to capture kinetics of reactions as they happen, and this can be with ambient temperature or pressure or elevated temperature or pressure. For pre-formulation, you may want to run solubility and crystallization screens and handle your samples with temperature controlled transfers. For sample prep, dispensing solids, liquids, viscous, slurries, different types of materials become important. All of this can be made possible on Stuntman. When we think about materials and energy research, on the other hand, the challenges look different, but when you think about it, the need for flexible automation is still the same. So with Stuntman, you can run AI-driven experiments, whether it is hydrothermal synthesis, catalyst development, polymerization, or even battery electrolyte screening. With Stuntman, you can handle slurries, solids, high temperature, high pressure reactions, real-time sampling, all of these catered towards the needs for materials and energy research. And for biologics researchers, whether you're running developability assessments to test different types of excipients, buffers, concentrations, or optimizing formulations, characterizing stability by doing stress studies like thermal or freeze thaw stresses, or pushing robustness and stress studies, Stuntman runs these informed screening of different types of buffers, additives, excipients, and ionic strength with automated measurements, all of that integrated into a single system so that your system can handle anything from sample prep to processing to stress studies to analysis, all end to end on a single platform. And Stuntman's capabilities are not limited to what it can do on a single platform. It can be expanded even further through integrations. And on this slide, you'll see some examples. So this can be just adding analytical tools. It could be adding different types of reactors. It could be adding different types of dispensing technologies or other specialized modules. Whether you're preparing your samples, processing them, but preparing your samples by sealing and labeling, or processing your samples by centrifugation or evaporation, or analysis by Raman analysis, UV-Vis, or EIS, or electrochemical impedance spectroscopy. All of these different tools and more can be integrated with Stuntman so you can expand the capabilities even further and beyond. So we started by talking about automation that executes without intelligence. And in this seminar, I hope that you've learned that Stuntman changes that with a shift in how labs operate. As I covered in the seminar, Stuntman is AI-driven, so it includes the built-in control layer, the AI, that basically helps you design, execute, and analyze, as well as iterate experiments programmatically. It connects design, execution, data logging, and AI-driven iteration into one continuous life cycle, so there's no friction in between these different steps, no handoffs that could cause delays. And it's fundamentally flexible with modular hardware, open APIs, expandable integrations that can basically adapt to your science as it evolves. So Stuntman isn't just about automation, but the foundation for autonomous, scalable experimentation that can help you grow from a single instrument into a fully automated lab or a closed-loop workflow. And this is what Stuntman makes me feel, and I hope it makes you feel the same way too. Very curious, very empowered, and a little bit wide-eyed about what could be possible on Stuntman. And really, the whole goal is really to make sure that with Stuntman, you are no longer wandering blindly, just trying to do random experiments, but really you can move forward with guidance towards your end goal and without any friction. And with that, I would like to open up for questions and bring Rick back on screen.
Thank you, Varojah, for taking us through how Stuntman embeds native AI into lab automation. It's a really cool topic, and how it translates scientific intent into executable experiments and enables fully autonomous, scalable experimentation. We've got some great questions so far, and we're going to go through a number of those. There's still time. You can ask questions. Just enter it in the Q&A section in your Zoom navigation bar. It'll be either at the top or the bottom. And let's start with a question here. You mentioned Stuntman AI is native to the platform. What makes it different from just using ChatGPT or Copilot to write scripts?
Cool. That's a great question. Thanks, Rick. Generic AI tools, like you mentioned, ChatGPT or Copilot, they can generate text or code as we already know it. But the limitation lies in that they don't understand hardware constraints that are specific to Stuntman. They don't know the experimental structure that Stuntman needs, or some of the execution rules that are required for running Stuntman. Stuntman AI that we've built for Stuntman specifically is purpose-built for the Stuntman environment, right? So what that means is instead of just generating free-form code like ChatGPT or Copilot would, Stuntman AI will end up generating code that is structured, compatible with Stuntman hardware, because it understands the plate formats, the mapping, and experimental parameters that are required for Stuntman, and also validation logic that's relevant for Stuntman. So that's what makes basically Stuntman AI native, or AI native to the Stuntman instead of using ChatGPT or Copilot.
Great, thanks, Varojah. Another question about can you start designs either from scratch, like from very, very basic, what you want, as opposed to already having a template or an experimental design? And what would be the options there to create an experiment?
Another great question. So as I showed in the seminar today, there are many different options of how you can interact with Stuntman. One is the GUI and the other is the programmatic Python scripting, right? So if you wanted to completely start from scratch, you can use the GUI to define your chemicals, define your libraries or plates, do the mapping, create step-by-step workflow. On top of that, after you create the design from GUI, what we have is this very cool tool, which we call Stuntman Convert, that will allow you to convert your design from GUI to Python script. So now you basically create a design from scratch using either the GUI interface, or now you also have this Python script available that you can run on Stuntman. So two different options, and then on top of that, both GUI and Python script allow you to modify those existing designs if you wanted to, or use those as templates to create new designs.
Great. We have a couple of questions about sort of the closed loop experimentation and how it works in practice and what flexibility users have in choosing the optimization methods.
Okay. So for closed loop with Stuntman, in this slide, I think you saw that you would prompt Stuntman what you would want to optimize on, right? So basically, as a user, you would go to Stuntman and tell your intent. Say that you want to optimize some kind of experiment. You want to optimize on some kind of parameters. So what you have to do to Stuntman or provide to Stuntman is your goal, your constraints, your optimization parameters, as well as your optimization strategy. So once that information is available, what Stuntman will do is basically convert that into a master script that can create a design, run the experiment, gather data, feed that data into the optimization algorithm, all based on what the user has defined it to be, right? And in terms of the optimization itself, there's a lot of flexibility around it. We don't hold you against like only what's available on Stuntman AI, so you're not locked into a single method, but you can actually end up using either open source Bayesian optimization algorithm, design of experiments. If you have proprietary ML algorithms, you can use that, or any open source Python frameworks that you're a fan of. You have openness to use any of those available for choosing the optimization method itself.
Cool. And can you clarify which AI models Stuntman uses and whether the system is running locally or in the cloud?
Sure, yeah. So we are using, so as you can see, our AI generates Python scripts. And what we've done is worked with Anthropic's Claude model as a large language model that our AI uses to generate these scripts. And the software itself, it runs locally on the system's computer, but the large language model runs on Anthropic's secure server.
Okay. And which large language models can be used with the AI layer? For example, can they use their own large language models as API calls or other?
So with Stuntman, we do provide Anthropic's Claude as the foundational model that drives it, but you do have flexibility. So if your company has your own choice of LLM you want to use, that is flexible. Again, you will have to train it so that you can provide it with the hardware constraints that the Stuntman needs, the parameters, the structural experimental structure that it recognizes so that it is compatible with Stuntman. And there is a flexibility, but there will be a little bit of extra work that you may need to do in terms of making sure that it's compatible with Stuntman.
And there were a couple of questions about hardware.
Mm-hmm.
Let me just. So one question was, is there anything different in the Stuntman hardware relative to the Junior and Big Kahuna platforms?
Yeah, there are a few key differences. So with Stuntman, the gantry that we are providing with Stuntman it's a gantry system that allows it to be more sturdy and robust, and it enables basically training to be more precise. In terms of the deck itself, so for those who know about our previous Junior and Big Kahuna platforms, we had these passive elements on both sides of the automation platform. And these used up quite a bit of deck space, but those shoulder or passive elements are now gone, which means you can have more active deck elements available on Stuntman. So within the same footprint, you get more capabilities available. On top of that, we are providing Stuntman with an enclosure that has a lot of flexibility. So you could have the enclosure that's just ventilated or have it upgraded so that it can be inertized. So if you're doing some, inert sense, environment sensitive chemistry, then you could basically inertize the enclosure and run sensitive chemistry applications as well. It also comes with an option for HEPA filter for making sure that the environment is clean for biologics applications.
Cool. And I think we're running close on time here, so we'll take kind of one more compilation of a collection of questions that have come in, and that's sort of around security and the models, and if you could speak at all to security for the AI application.
Absolutely. Yes, we are all aware that AI is a good tool, but also data security is something that's very key and vital to a lot of our customers. So as I mentioned, the software itself runs locally, but the LLM runs on Anthropic server. There is any data that is required for creating the design and script will be passed between through the server, but Anthropic does not retain that data over time, and it is all the data passing is encrypted. So there is no training of by Anthropic using your of their models using your data, and no retention of your data in their server.
Great. Well, thank you, Risha, for answering all these great questions and for the wonderful presentation. I also want to thank everyone who joined us live today. If you'd like to have a deeper conversation with our team, please do get in touch with us at info@unchainedlabs.com or learn more about our website at unchainedlabs.com. We'd love to connect with you. Again, thank you for attending our virtual seminar, and we hope you have a great rest of your day.